Hello. So I was just looking at the Hacker News and noticed this article. IO is no longer the bottleneck, in which the author, let's open it. The author is saying that contrary to popular belief, IO is not longer bottleneck in typical programming interviews problems. And this article reminded me that so few developers understand that it's almost never CPU, memory, disk IO, or networking that is the bottleneck. The bottleneck is almost always the latency. So your CPU can go through a lot of data, like gigabytes of data. Your memory can go through gigabytes per data. Your disk can go through gigabytes per data per second. Your networking, your disk, all of them can do gigabytes of data per second. But their latency of operations on them is actually not that small, and it quickly adds up. And in modern software development, almost all practices tend to ignore it. They just think that just because something can, in perfect conditions, pump, I don't know, let's say here 12 gigabytes per second, that means you don't have to, like, you can stop thinking about the performance there. And this is not true because, let's say, a memory and the CPU, they can go through tons of data, but only if that data is linear and when you work on batches of it at the time. And in most programming languages, when you allocate left and right, if you scatter all your objects on the heap in random places, and then you want to go through it in sequence because you operate on like a million of something, and your CPU has to issue a request to get given chunk of memory, then do something on it, and then has to issue a request to fetch a different piece of memory and wait for it to finish and then work on this. Those little latencies on millions of objects add really, really quickly. And you're not gonna see any of those numbers. And it's just most like game developers will always write their engines using data-oriented architectures of some kinds, like ECS, entity component system, precisely so they keep everything in large chunks of linear memory, so they can go through everything and apply their transformations on thousands of millions of things at the same time, precisely so they can avoid the latency. Then if you're working on maybe web application that does database queries, if you write your operations as larger batches that operate on a lot of things at the same time, then things can be really fast. But if you write your, let's say, application, some kind of an API handler, as its issue a small batch to do something, waits for it to complete, then does another, and it needs to do like 100 of those, even though each of them can touch a very little piece of data. The latency of it, every request to the database is going to be a couple of milliseconds, and that quickly adds to seconds, and the user sees that the request is taking a couple of seconds to handle. Same with files. If your software is opening one file just to read a little bit of data, process it, then opens another file just to read another stuff. If you need to go through hundreds of files, even if the operations you're doing there are small, it's going to add up, and it's quickly add to seconds. That is really the whole reason why modern software is ridiculously slow, even though the hardware on every level got really, really fast, because everybody keeps ignoring the latency. And yeah, if you can write your software so it works on larger groups of data, if you can lay this data sequentially in memory, like typically in some kind of an array, and go through it from the beginning to the end. If you can operate in data in batches to amortize the latency of I/O, if you can parallelize to hide the latency, because instead of your software waiting on one thing at the time, it waits on 100 things at the time, so those latencies compress. If you can write your software to make smaller numbers of requests, networking requests, or parallelize those requests, you can get really impressive performance. But you need to fight with latency. And then talking about like I/O is a bottleneck or CPU is a bottleneck, you really need to eliminate a lot of kind of low hanging fruit latencies before you can even start to hit the maximum throughputs of components in a modern computers. So I wouldn't worry about, is it I/O or networking or CPU or memory. It's always latency. As long as you remember, as long as you pay attention, as long as you architect to avoid waiting for stuff to finish, your software is going to be fast. Everything else is kind of secondary, or it's like something you take care when you really optimize uh, the the obvious, not so obvious because most people are not aware of it, but the important stuff. Latency. It's always latency. Thanks. Bye.